in this lesson, let's learn about variation. There are three aspects to it. One is in direct variation or direct proportion. The second one is linked but not in direct proportion. The third one is inversely proportional or inverse variation. And we'll sum up all of these things. We'll wrap this with one illustrative example and understand how to solve questions that come in variation. Let's start with a definition and understanding about what this direct proportion or varying directly is. This is a definition of it. A is said to vary directly with B when the relationship between A and B is such that when B is changed, A also changes in a constant ratio. That's the crux of it. If I change B, A also has to change, and it should change in a fixed constant ratio. How do we express this? We typically say that A is proportional to B. This is how it's written. This symbol is used for representing this proportional. The proportionality is usually converted into an equation by adding this constant factor. This is a ratio in which it changes. So A varies directly as B is what the symbol means. Expressing it as an equation, this is A is equal to KB. What it essentially means is, if I change B by 1 unit, A will increase by K units. So that's the idea behind this thing. Let's look at a few examples. Example of a direct variation, a very straightforward example is, let's say the price of an article is equal to $50. If you buy one article, you'll pay $50. If you buy 10 articles, you're going to be paying $500. So the amount of money that you pay is directly proportional to the number of articles bought, provided the price per article or the cost per article remains unchanged. So what we'll say is the amount paid is directly proportional to the number of articles. A is proportional to B. What is A here? The amount paid. What is B here? The number of articles bought. So writing it in terms of an equation, we'll say amount paid is equal to K times the number of articles. What is K? K is the price per article. So if I buy one article and the price per article is $500, I'll end up paying $500. If I buy 2 articles, I'll end up paying $1,000. If I buy 10 articles, I'll end up paying $5,000. So this is the idea behind direct proportion. If B increases, A increases in a constant ratio, and that constant ratio is what we'll usually find out when you're trying to solve these questions. Let's move to the second idea, which is linked but not in direct proportion. There are quite a few instances. A and B will tend to move in the same direction. If A increases, B will also increase, but the ratio will not be a fixed ratio. Those are what are called as linked. In real life, many times you will find that most things are linked but not in direct proportion. Let's look at a couple of examples. Right? Let's say a child takes 3 years to learn to count from 1 to 10. From the time a child is born, she will take 3 years by the time she counts 1 to 10. So can we extrapolate saying that if she has to count from 1 to 1000, instead of 1 to 10, we have increased the count by 100 times. So can we immediately infer that she's going to take 100 times as much time and she'll be able to do this only when she's 300 years old? It's obviously absurd, right? As she grows older, the number of numbers, her count value is going to increase. Instead of 1 to 10, she'll be able to count 1 to 1000 in more days than it took her to count from 1 to 10. But it is not going to vary directly. Probably in 3 years and 1 month itself, she'll be counting from 1 to 1000. So as her age increases, the number of numbers that she can count also increases, but it is not increasing in the same constant ratio. That is what is known as linked but not in direct variation. Let's take something which is closer home for students. Let's say I tell a student that if you prepare for 100 hours, you will get 50% marks. So if the student turns back and asks me, so if I prepare for 300 hours, the number of hours he or she is preparing goes up to 3 times of what I mentioned. Will the student get 150%? That's not going to happen. As you increase the number of hours of preparation, you are likely to get more marks. But there's a cap. You can only go up to 100%. So however many hours you increase, it's not going to breach that 100%. So increasing the number of hours is going to increase your score. Number of hours goes up, your scores also go up, but it is not going to maintain the same fixed ratio. So that is what is known as linked. Here are a few other examples where we'll see it in the question the way it appears. This is an example when we say that this is square of sales is proportional to the cube of expenses. So square of sales is directly varying as cube of expenses. Sales is linked to expenses. Sales is not directly proportional to expenses. Another example, incremental sales. The square of incremental sales is proportional to the square root of expenses. Incremental sales is not proportional to expenses. Incremental sales is linked to expenses. So incremental sales and expenses do not have a direct variation. So this is the idea behind linked. The last one, let's look at inverse proportion. Inverse proportion, we'll start with direct proportion once. A is said to vary directly with B if an increase or decrease in B is met with a corresponding increase or decrease in A. So if A is proportional to B, then if B increases, A will also increase. B decreases, A will also decrease. Inverse proportion is exactly the opposite. A is said to vary inversely with B. If B increases, it would be met with a corresponding decrease in A and vice versa. So A, B, if I increase B, if A decreases, then it is inversely proportional. Conversely, if I decrease B, if A increases, then again we'll say that it's inversely proportional. How do we represent this? Inversely proportional is, look at an example before we go to the representation. Speed and time for a constant distance is inversely proportional. Let's say I cover a distance of 100 kilometers. If I travel at a speed of 100 kmph, the time required will be 1 hour. If I reduce the speed to 50 kilometers per hour, it becomes half of it. The time required will be 2 to cover the same distance of 100. So at a constant distance, speed and time vary inversely with each other. Or in other words, if I double speed, time becomes half. If I halve the speed, time becomes double. How do we represent it? The symbol for representing inversely proportional is A is proportional to 1 by B. If you write it in an equation, we'll say that A is equal to K by B, or cross multiplying it, AB is equal to a K. We'll put this to use with an illustrative example. An engine moves at the speed of 40 kilometers per hour without any coaches attached to it. The speed of the train reduces at a rate that varies directly as the square root of the number of coaches. So the reduction in speed is linked to the number of coaches, but it is not in direct proportion. They've given us a couple of instances and they've asked us we need to find out the speed when there are 36 coaches. We'll come to all of these, we'll use them, we'll come to them eventually. Let's start with setting this question up. Here it says that the speed is equal to 40 kilometers per hour without any coaches attached. If you attach coaches, the speed is going to decrease. Let's say it comes down by a delta S. The quantum by which it comes down is delta S. By what quantum does it come down? That's what this statement tells us. There's a word problem. Let's watch it very carefully. Pick each sentence, interpret it, and frame the equations appropriately. Otherwise, you won't get the right answer. The speed of the train reduces at a rate that varies directly. This reduction in speed varies directly as the square root of the number of coaches. Let's say the number of coaches is equal to n. It says that delta S is proportional to root n. Any proportionality, we can make it into an equation by adding a constant. So delta S is equal to k root n. Now let's plug this in here. So the speed is going to be equal to 40 minus k root n. So this is the equation that we want. If we can find out the value of k using this instance that's given, then we'll have one equation which will be in such a way that S is equal to 40 minus, let's say k is equal to 2 for a moment. So if the equation, this is not the correct answer, but let's just assume for a moment, S is equal to 40 minus 2 root n. If someone gave us a number of coaches, we can find the speed. Someone told us the speed, we can find out how many coaches are attached. So the objective first is to find out the value of k using this information. Just put together this thing in a printed form. We'll see that first before we find out the value of k. Right? This is what the speed of the train, the engine without any coaches is 40. It decreases by a delta S. So speed is going to be equal to 40 minus delta S. What is said about this delta S? This delta S is proportional to the root of the number of coaches. So delta S is equal to k root n. So we can say the speed of the train is going to be equal to 40 minus k root n. As I mentioned, let's set about finding the value of k. Let's use this information to get that. We know S is equal to 40 minus k root n. The question says if n is equal to 4, the speed becomes 32. Let's just plug that in here. Speed 32 is equal to 40 minus k into root n, which is equal to 4. So k root 4 is equal to 2k. Let's take it to the left hand side. 2k is equal to 40 minus 32, which is equal to 8. Or k is equal to 4. This is our equation. Let's replace this k with a 4. So s is equal to 40 minus 4 into root n. What do we have to find out? What happens to the speed when there are 36 coaches? Substitute n is equal to 36. We'll find out yes. If someone gave us the speed, we can find out n. Here we know n, so let's find out speed. This is equal to 40 minus 4 into root 36. Root 36 is a 6. 4 into 6 is a 24. 40 minus 24. The speed of the train is going to be equal to 16 kilometers per hour. Whew. We covered quite a bit in this video. It's a lot of concepts to cover in one single video. Time we took a break. Use the break for two things. One, subscribe to this channel. And two, sign up for the most comprehensive and affordable GMAT Quant course that's available online at gmat.wizako.com.